Hi everyone. All right, so a couple of you have asked some really great questions that are relevant to assignment 1. And so I'm going to give you just a couple of tips, primarily about how to delete a variable if you know you've messed up coding that variable, and also how Stata handles missing variables. When you're recoding a variable, does Stata keep the missing cases missing, or does it accidentally recode them? And we touched on this in class, but not enough to solidify what you need to do for assignment 1. And if you've already done it and you didn't take these into account in doing your assignment, that's perfectly fine. This is knowledge that will still serve you in future chapters, and I won't count you down for not including it in this particular assignment. Okay, so I'm going to open up a do file that I created for this assignment. I have an assignment 1 do file. Now remember, in the log file and do file video touted the benefits of using a do file instead of using the command window, and that is you can write out all this code, you can leave comments to yourself, you can return to it later on and continue on a particular project. So I created a do file for assignment 1, and I'm going to run this so that you get the added benefit of seeing how a do file works once it's created. So the very first thing that I do, I open up Stata. I've opened up the do file that I created previously, and I'm going to highlight this log using. Notice I only have to highlight the first word, and then I'm going to click on execute selection. That opened up the log file that's going to allow us to save the output, and I named it assignment1.log. It's saved in the log files folder in 318. I used replace so that it copies over any previous log file that has this name. Sometimes you don't want to do that. You can just change the name and have cumulative log files for each session. Then I'm going to highlight the use command, and we know what that does. It opens up the data set, and we can see that now we have the GSS 2016. That's the data file that we're using for assignment 1, and all the variables have now been added in Stata. If I want to filter, we're only using one particular variable, and that's the age of the child, the respondent's age when first child was born. So we can use this filter box so that we have that variable handy there. And now I can start the process of creating the new variable. So generate age kid born 2 equals age kid born 1. And this one is simple. I'm sure everyone was able to figure this out. We just name the new variable and make it equivalent to the first variable. Why do we do that rather than just recoding the original? Because it's always good practice to keep the original variables as they are so that you have the unedited versions of those variables in case you realize you made a coding error down the road. You can still use that variable. Otherwise, you'd have to go back to the very raw data set that you downloaded from wherever it was, from the GSS website in this case. All right, the second thing we do is replace. But I've included an error here on purpose to show you that sometimes if you try to replace the variable and realize you've made a mistake, and then you try to run the generate command again, you can't generate the same variable because it's going to give you an error that that variable's already defined, right? So yeah, we already generated age born 2. We tried to code it to make it equal to 1 if the original age kid born was less than or equal to 30. And then I realized I made a mistake. Actually, I wanted less than 30, not less than or equal to, because it asks us to code the categories under 30 equals 1. So under 30 would be just less than 30 as opposed to less than or equal to 30. We didn't talk about these nuances. So I realize I made a mistake, and now what do? If I try to recreate that variable, I'm stuck with this incorrect variable. So what you need to do is use the command drop. That allows you to then delete that erroneously coded version of the variable, and then do the generate and replace all over again. So I'm first going to generate age kid born 2 equals age kid born. That's the same thing I did up here. Now I'm first going to replace with to be equal to 1 if the original variable is less than 30. Here's a tricky one that you may not have been able to figure out. I'm going to replace it to be equal to 2 if the original is greater than or equal to 30. We want it to be greater than or equal to rather than just greater than. Otherwise, if we have less than 30 and then greater than 30, we're actually omitting all the people that are age 30, right? So we do greater than or equal to 30 and less than or equal to 40. Notice we have to repeat the variable name. If I try to run this command without the variable name, I'm going to get an error, and I may not know why. So the correct command is this one, which is equal to 2 if age kid born is greater than or equal to 30 and age kid born is less than or equal to 40. Okay, so that was the first tricky thing. Now the second tricky thing is this is the command that I want to use for the final category, equal to 3. The book asks us just to have over 40. But one thing that we didn't talk about is that Stata considers missing variables, right, coded as the periods, dots, to be the highest values. So higher than any other value. So if we specified simply greater than 40, actually all the missing variables on this variable would be coded, all the missing cases would be coded erroneously as over age 40. And we don't actually know that they're over age 40. They're missing information, right? So they could have been younger. We don't know. So we need to add, anytime we code with a top category that has greater than or equal to some number, we also want to use and less than missing so that the missing cases remain missing. Now, how do we double check if this worked? We can do two things. First, we'll tabulate the new variable and we go, okay, so the new variable oops, I forgot to run this top category, and now I see that I'd made a mistake because I was expecting to see the new variable to be equal to 1, 2, and 3, but it actually is equal to 1, 2, 41, 42, 43, right? So that tells me, oops, I forgot to run this last replace command. So now that I've done that, I can run the tab command, and I messed up again because my comment here messed up running the previous command. Okay, so now I'm going to run tab and I'll see that I have 3 categories. That is what I expected. But now how do I figure out if these are the categories that I should have? Well, I can browse comparing the new variable and the old variable and just make sure that those who are coded under 30 are indeed in category 1. Those who are missing remain missing. Those who are in 30 to 40 are in category 2, and so on. So I can eyeball it. This is way too big of a data set to be able to verify it for all of the cases. The other thing I want to look at is make sure that the total number of cases for age kid born is the same as the total number of cases for the original variable. So, oops. So sometimes my fingers move too fast. So I'm going to tab the original variable, which is the age kid born, and see that, okay, there are 2,056 people in this variable, and those same 2,056 people are included in the new variable. That's a good sign. If there were a discrepancy, I'd know something went wrong. And now I'm going to show you how you could have gone wrong. And that is if you omitted this less than missing, as we discussed, you would end up coding the missing people as the top age category, and we'll see what that looks like here. So here I'm going to create age kid born 3 equals age kid born, and then I'm going to replace, keeping everything the same except for the top category does not have the qualifier and age kid born is less than missing. So now let's see how many cases are included in this version. 2867. Oops. All right. So now I see I should have only had 2056 because that's what the original variable of age kid born has. But now I see that I've erroneously included those missing cases in this top category. Notice the top category 3 has 829 in this version of the variable versus only 18 in the correct version of the variable. All right, so this gave you 2 pieces of information that I think are very important moving forward, and if you have not yet done this assignment, you now know how to do it correctly and things to look for, and that is how to drop variables if you've made an error when you're coding and you want to, instead of renaming and creating a 3rd or 4th or 17th variable. Sometimes I make lots of errors and find myself with different different versions of the same variable. And so instead of just risking keeping those erroneous variables in your data set, you drop the version that you know is incorrect and then recreate it. So we learned how to use drop, and then we also learned that, very importantly, missing cases are considered to be the highest value in Stata. And so when you're coding a top category, you always want to include and that variable is less than missing to make sure that missing cases stay missing. All right, I hope this was helpful to you, and good luck with your assignments.